Hello and welcome to Lesson 10.6. Today we're going to look at what we call the quadratic formula. Now the quadratic formula is awesome because you can use this formula to solve any quadratic function. So if you are struggling with factoring or if something can't be factored nicely, you can use the quadratic formula. And as you can see here, the function says that x equals, because remember these are really our x-intercepts, x equals the opposite of b plus or minus, this will produce two different answers, the square root of b squared minus 4 times a times c, and then we're going to divide that by 2a. This is a very, very important formula. You must learn to memorize this because this is something that you will use for the rest of your math careers. But it's so incredibly awesome, I don't know why you wouldn't want to memorize it. The only thing you have to remember is in order to use the quadratic formula that it has to be written in standard form first. And if you remember, standard form is going from the largest exponent all the way down to the constant. So for example 1, it tells us to solve x squared plus 6 equals 5x. Well, if you recall, we said the only stipulation in using the quadratic formula is that your equation has to be written in standard form. So the first thing we're going to do is we're going to write this in standard form. So I need to subtract my 5x from both sides, and that's going to leave us with x squared minus 5x plus 6, and it's going to be equal to 0 on the right-hand side. Now that I have this written in standard form, I'm just going to memorize my equation, and again, that's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So I'm just going to plug in my values. So x equals, my b value is a negative 5, so I want to take the opposite of that, which makes that a positive 5, plus or minus the square root of b squared, or 5 squared, minus 4 times my a value, which is 1, and my c value is a positive 6. And then I'm going to divide this whole thing by 2 times my a value, which is 1. So now if I simplify, I have 5 plus or minus the square root of 25 minus 4 times 1 times 6 is really 24, all divided by 2. And if I continue to simplify this, this is really 5 plus or minus. Well, this 25 minus 24, this whole thing is going to go to 1. And if I square root 1, I really have 5 plus or minus 1 divided by 2. So I'm going to break this up into two answers where I have 5 plus 1, which is 6, divided by 2, or 3. Or I can go 5 minus 1, which is 4, divide that by 2, and I get 2. So my two x-intercepts are when x is equal to 2 and when x is equal to 3. So these are the solutions to this quadratic equation. So for example 2, we're told to solve 2x squared plus 4x minus 7 equals 0. I would highly suggest that you write your quadratic formula down at the beginning, especially until you have it memorized. And again, it's the opposite of b plus or minus the square root of b squared minus 4ac, that whole thing divided by 2a. Now my equation is written in standard form, so that's nice. So now I'm just going to plug in my values. X equals the opposite of b. Well, in this case, my b is a positive 4, so that makes this a negative 4, plus or minus the square root of b squared, or 4 squared, which is 16, minus 4 times 2 times a negative 7, all divided by 2 times a, which is 2. And if I simplify, I have negative 4 plus or minus the square root of 16 minus a negative 4 times 2 is a negative 8 times a negative 7. Well, that actually becomes plus 8 times 7, which is 56. And I'm going to divide that whole thing by 4. So again, when I simplify, I have negative 4 plus or minus 16 plus 56 is the square root of 72, and I'm going to divide that whole thing by 4. And now this doesn't specify if it wants an exact answer or if it wants it as a decimal, so we'll just go with the decimal route for now. And I'm going to break this up into a negative 4 plus the square root of 72 divided by 4. And I'm going to break this bottom one down into negative 4 minus the square root of 72 divided by 4. And if I type that into my calculator, I get 1.12. And for the other one, I get a negative 3.12. So these are my two x-intercepts, or my two x values. Example 3 says to solve negative 3x squared plus 5x minus 2. Again, this is written in standard form, so I'm just going to write my quadratic equation as the opposite of b plus or minus the square root of b squared minus 4ac at the top, all divided by 2a. So x equals the opposite of b, or a negative 5, plus or minus the square root of 25, which is b squared, minus 4 times a times c, all divided by 2 times a negative 3. So when I simplify this, this is negative 5 plus or minus 25 minus 24, all divided by a negative 6. So 25 minus 24 is again going to give me 1. The square root of 1 is 1. So my two solutions are going to give me negative 5 plus 1 divided by a negative 6, or I end up with negative 5 minus 1 divided by a negative 6. So if I simplify, negative 5 plus 1 will give me a negative 4. A negative 4 divided by a negative 6 is really going to give me a positive 2/3. And for my other one, I have a negative 6 minus 1, which is going to give me a negative 7, divided by a negative 6 is going to give me a positive 7/6. So these are my two solutions to this quadratic equation. So one last thing I want to go over before we do our final example is what we call the vertical motion model. Now the vertical motion model looks something like this. This is the standard equation. It says h equals negative 16t squared plus vt plus c. T is going to be measured in time, or is the measurement of time in seconds. V is going to be our initial velocity, and that would be in feet per second. C is going to be the initial height in which the object was released from, or thrown from, or launched from. And then your height is going to be the height at any given time. Okay, so if you recall, like if I have an object that's going something like this, and this is the ground here, okay, this distance right here is c, because that's my initial height in which the object was released. We'll say it was being released from a building or something. So we'll call that height c. And then h could be at any point along this curve depending on what time we're looking at. So we're going to use this equation in our next example. For our last example, it says suppose a football player kicks a ball and gives it an initial upward velocity of 47 feet per second. The starting height of the football is 3 feet. It says if no one catches the football, how long will it be in the air? Okay, so if I have h equals a negative 16t squared plus vt plus c, I've got some information I can plug in. I know that h is equal to a negative 16t squared. My velocity, I was told, was 47t, and my initial height is 3. So I can plug in all the values that I know, and now I have a quadratic equation. Well, my problem says it says specifically, if no one catches the football, how long is it going to be in the air? So ultimately, how long means I'm looking to solve for time. So I'm solving for t. But now when it tells me that no one catches the football, I'm essentially looking at a height of 0 for this, because that means that football has hit the ground. So now I have 0 equals a negative 16t squared plus 47t plus 3. Now I have a quadratic equation written in standard form, set equal to 0, and I can go ahead and solve. Looking at this equation here, this isn't something that's going to factor nicely at all. So I won't even attempt it. I'm going to go straight into using the quadratic formula. So I'm going to say t, which is really my x value, is the opposite of b, or negative 47, plus or minus b squared, or 47 squared, minus 4 times a times c, all divided by 2 times a. So if I simplify this, this gives me that t is equal to a negative 47 plus or minus the square root of 2,209 minus, which actually I have a double negative, so this is going to become plus 192, all divided by a negative 32. So I can simplify this, and this stuff underneath the radical, this is really going to become the square root of 2,401, and I'm going to break this up into two equations now. So my two equations are going to be when t equals a negative 47 plus the square root of 2,401 divided by a negative 32, and when t equals a negative 47 minus the square root of 2,401 divided by a negative 32. So if I type this into my calculator, this is going to simplify down to a positive 2 divided by a negative 32, which gives me a negative 1/16, or that's roughly a negative 0.0625 seconds. And if I calculate the other side of that, I end up with 3 seconds. Now, because this is a real life situation, it does not make sense to have a negative time. Therefore, in this situation, I'm only going to have one answer, and that would be 3 seconds. Now, to wrap up this section here, okay, we've learned a couple different ways that we can solve quadratic equations. One, you can graph, okay? Works nice if you have graphing paper or a calculator handy. Two, you can use square roots, but that only works if you have no middle term or no x term. You can factor, but this only works well if you can factor it easily. We did not cover the completing the square method, so you can ignore that. Or you can use the quadratic formula. I myself will typically either use factoring or the quadratic formula. These are my two preferred methods. You can use whatever method you prefer. If it factors nicely and easily and quickly, I'll use the factoring. If it doesn't, I'll go straight to the quadratic formula. Please let me know if you have any questions. Otherwise, have a great day, and I will see you guys in class.